Welcome. In this video, we shall cover some important theorems relating to transient and persistent states and the relation between the P jkn and f jkn. Now let us enjoy the video. So now, what is an essential state? So now, what is an essential state? A state J is essential if whenever Ej to Ek, we must have Ek to Ej. Otherwise, the state J is called as inessential. We have Fjk 0 equal to 0, Pjk 1 equal to Fjk 1 and Pjj 0, this is also equal to 1. Now, we define Pjks be the probability generating function of Pjk n. Then Pjks, that is equal to summation n equal to 0 to infinity Pjkn to s to the power n, where mod s less than 1. Now define Fjks be the probability generating function of Fjkn, then Fjks equal to summation s equal to 0 to summation n equal to 0 to infinity Fjkn s to the power n, so mod s less than 1. Now there are some important theorems. Theorem. If j not equal to k, pjk pjk s equal to fjks into pkks. The second, if j is equal to k, pjjs equal to fjjs into pjjs plus 1. Now let us prove these two theorems. Consider two infinite sequences, infinite consider two infinite series summation n equal to 0 to infinity an s to the power n and summation m equal to 0 to infinity bm s to the power m. Now we multiply these two series such that summation n equal to 0 to infinity n s to the power n into summation n equal to 0 to infinity bn s to the power n, that is equal to summation r equal to 0 to infinity cn s to the power n, where cr s to the power r, where cr equal to a0 br plus a1 br minus 1 plus up to so on ar b0. Now using this we shall find the product of two series. Now we consider now pjks, that is equal to summation n equal to 0 to infinity pjkn into s to the power n, where mod s is less than 1. Now this is equal to summation n equal to 0 to infinity, and this is summation n equal to summation r equal to 0 to n fjkr into pkk n minus r into s to the power n. Now this will be equal to summation n equal to 0 to infinity, summation r equal to 0 to n fjkr into s to the power r into pkk n minus r s to the power n minus r. Now this will be equal to summation n equal to 0 to infinity fjkn into s to the power n into summation m equal to 0 to infinity p kkm into s to the power n. Now this is equal to fjks into pkk. So which proves the first one. Now for the second, we know that pjjn equal to summation r equal to 0 to n fjjn into pjjn fjjr into pjjn minus r, where n is greater than equal to 1. Now this implies summation n equal to 0 to infinity pjjn into s to the power n. This is equal to summation n equal to 0 to infinity r equal to 0 to n fjjr into pjjn minus r s to the power n. Now this will be equal to summation r equal to 0 to infinity fjjr into s to the power r into summation n equal to 0 to infinity pjjn into s to the power n. Now if we write AR, that is equal to fjjr BR equal to pjjr, and then CR equal to fjj0 into pjjr plus fjj1 pjj r minus 1 plus up to so on plus fjj r pjj 0. So pjj equal to k equal to 0 to r fjj k into pjj n minus k. So this implies pjj is equal to summation pjjn raised to the power n. So this implies pjjs minus 1 that is equal to fjjs into pjjs. So this implies pjjs equal to fjjs into pjjs plus 1. So now pjjs to 1 minus fjjs equal to 1. That implies pjjs equal to 1 by 1 minus fjjs. Now we have pjks equal to fjks into pkks. So that is equal to fjks by 1 minus fkks. So we can write pjks equal to fjks divided by 1 minus fkks. fkks. From this we study the recurrence relation. Now there is a corollary. Suppose k is a persistent state. Persistent means P jkn greater than 0 and f jkn also greater than 0. Then summation n p jkn, this is equal to infinity. So we shall prove this. Now we have the relation pjk s equal to fjk divided by 1 minus fkk s. Now taking limit s tends to 1 minus, limit s tends to 1 minus pjks equal to limit s tends to 1 minus fjks by 1 minus fkks. Now this implies this is summation n equal to 0 to infinity pjkn, this is equal to summation n equal to 0 to infinity fjkn divided by 1 minus summation n equal to 0 to infinity fkk. Now if the state if k is persistent, then summation n equal to 0 to infinity fkk n, this is equal to 1. So summation n equal to 0 to infinity pjkn, this will tends to infinity. So when k is persistent, so this establishes the corollary. Now let us have another corollary, second corollary, corollary 2. If j and k are communicable with each other and k is persistent, then j will be also a persistent state. Now since k is communicable, j and k are communicable with each other, we have k can be reached from state j and also j can be reached from state k. Now when j to k we have p jk m greater than 0, and when k2j we have pkj n, this is greater than 0. Now consider pjj m plus n plus me, that is equal to summation pjk m pkk nu pkj n. Now this is greater than equal to p jkm pkk nu into pkj n, summing over me. Now this is greater than equal to p jk m p kjn summing over nu equal to 0 to infinity pkk nu. So now since nu equal to 0 to infinity p jj m plus n plus nu is the partial sum of n equal to 0 to infinity pjj n equal to infinity. So then we must have n pjj n, this tends to infinity. That means state j is persistent. Now another corollary, if j and k are communicable with each other and if k is transient, then j will also be a transient state. The proof is similar. That means if j and k are two communicable states, if j is transient, then k will be transient, and if j will be persistent, k will also be persistent. So these are the important relationship between the communicable states. That means if different states are communicable with each other, then all the states will have the same property. So let us consider some important points. state J, we know that state J is aperiodic. If its period dj equal to 1. Now the second limit n tends to infinity pjjn equal to 1 by mu jj, where mu jj is the mean recurrence time to reach the state j, that is equal to summation over n f n into fjjn. So if j is aperiodic, but if j is a periodic state, with period dj, then limit n tends to infinity pjjn equal to dj by mu. Now these are some important remarks we have to consider while solving the problems. If the Markov chain is irreducible, then all the states will have the same properties. That is an irreducible chain all states have same properties. So these are some important points we have to consider. Thank you for enjoying the video.